So today we will talk techniques of the edit sketches like the chamfers, filters, fillets, making the mirrors, pattern the feature. So they are the very useful techniques. Yes, please. Sorry. Sorry. I forgot it. Okay. Thank you. Now, can you see my screen? Okay. Today we will talk about the techniques, so-called edit sketches. So, like the fillets, making the fillets, edge blends, and making the mirror of the features, and make the pattern the feature circular and rectangular linear pattern. So, in order to do this, always select the sketch and sketch the plane, any plane, for example this one does not matter. So press OK. So here in the direct sketch, you see here we have seen basic technologies of the sketch like the rectangle, circles, line, and so on. Today we will see some edit curves like here. It is the chamfer, fillet, the trim, extend, make corner, and so on. Here you see pattern, feature, offset, and making a mirror. So we will see all of them step by step. For the beginning, I would like to draw the rectangle. So any rectangle, for example, so with 2 points on. So I don't define the dimension. Here you see the dimensions that we have seen. There's the outer dimension. First here, see making the chamfer. Select this one, and you see this one is open, and here you have to select the lines where you want to obtain the chamfer. First of all, let's make the chamfer method as a symmetric first method, and here select the line. For example, this line and this line. So you see, if I move my mouse here, you see here the chamfer is creating. So here you see the values of the chamfer, and here you see the, for example, let's make the value is the 10. Press enter. Sorry, just one more again. Here let's make the chamfer here. Here the value, you see, the value is 24. Let's make it a 10 and press enter. You see, here the chamfer is created with the method of the symmetric. It means it's the 10 millimeter from this side and 10 millimeter from this side. So you can create the chamfer like this. For example, let's create the chamfer for this side also. This one and this one, if you move your mouse, the chamfer is creating. You can give the different value, for example 20, since it is a symmetric. You see 20 from this side and 20 millimeter from this side, symmetric way. So in this way you can create the chamfer for the corners, so with the different values or the same values. So this is the first method of the how to create the chamfer. So let's go on with the other method. For example, let's draw again rectangle. Go to the chamfer, and here select the method of the asymmetric chamfer. So you see in the case here you got two distance, 20 and 26. It is the two distance. For example, here in the select the curve, select the line, the function, select this line and this line. So you see here the values 28 and 28. For example, press to close it. So one more again. Here let's make its first value the 20, and second value let's make it bigger, so 30. So it is the asymmetric method. So select this one and this one. You see chamfer is created with a asymmetric way, 20 and 30. We can see one more example on the this edge. So let's make it a bigger value, for example 50. First distance is 50, second distance is 30. So now we select the lines, this one and this one. Sorry, just a moment. Just a moment. So 50 and 11. Okay, let's keep it 50 and 11. Press this one and this one, and press enter. So sorry, this is it comes to 0. Let me check again. So now it will come that this is the 50, 11. Sorry, this is the 11. So this is the 50. This is the how to obtain the asymmetric chamfer. So in order to be the clear, let's make it again. Change the asymmetric. So two values. You can make the two values as a symmetric or asymmetric. Does not matter. 10 and 20. And from here, select the lines. This line and this line. Okay, and you can, for example, let's make it 30. So here you see I obtained the chamfer with the 10 and 30. Okay, so let's draw again the rectangle. Select the chamfer again. Here the last type of the chamfer is a offset and the angle. You see this is the distance and this is the angle. You can make also the chamfer with this method. In this case, let's keep it this one, the 45, and select this one and this one. So press N. You see that with the angle you created with the 45 and this distance is the 40. So the chamfer is created. Let's see the example again. So with the offset, let's make the offset is the 30 and select the edge here, this one and this one, and let's make it 45. So okay, this is this method. So it is clear how to create the chamfer with the three methods. You can create a symmetric chamfer, asymmetric chamfer, and offset and angle. Clear is it? Everything? Can I continue? Okay. Let's go on, and next is the making the fillet. So rounded edge with the radius for the uh, for the for the sharp edges. So here you see the fillet function. In the case of the fillet function, though, it creates a rounded edge with the radius. So in this case, you have to select the edge, for example, this edge and this edge. So you see, if you move the mouse, the radius is creating with the different values. So you can type the value, for example, 25, and press enter. You see your value, the edge becomes the rounded with the value of the 25 radius here. The same way you can create the radius for the other edge, for example, this one and this one. Let's make it 30 and press enter. It is too easy. There is no special ways of the creating the fillet like the chamfer, just one way. Only creating the chamfer has the different way with the here. In this case, you will not delete here it is a corner is deleted. In this case, you will not delete the corner like this. If I press here, you see the corner is remained, but it is not unwanted things for us, so it is better to delete the corner with this method trim. There is a second one is untrim. So trim method is the most useful and the most effective way of the making the fillet on the corners. Also, you can make the corner or the chamfer with the intersection of the vertical and horizontal lines as well. So, for example, check the fillet, this one and this one, you see radius is created. The same way you can create the chamfer for the such kind of intersection of the horizontal and vertical lines. So this is the just the fillet, making the fillet. It is easy. So next is the quick trim. It is very useful tool. So very useful, very often I use the tool. For example, we have the system like this. For example, connection between the connection between the uh, connection between the whole rectangle and with the, for example, the circle, like circle, and I want to make the, I want to delete unnecessary parts of the this element. For example, this lower side of the circle and this side of the rectangle. In this case, I will choose the quick trim from the here. You see, quick trim, and I select this line. So you see, it is the highlighted with the red. It means it will delete the line until the intersection with the another line with this line. So I delete this one. So it is the deleted, remaining just upper side, and I want to delete this one. So if you select this one, you see it is the deleted until the select intersection of those another line. So you see I obtained this kind of or this kind of combined element of the rectangle with the circle. So with the quick trim you can obtain such kind of things. So for example, if you have such a, for example, intersection systems, so with the quick trim, if you want to select this one, you delete only this part. If I select this one, I will delete this one. So if I select this one, I will delete this one. So until the intersection with the another line. So just for the information, here if you have the some elements, intersectional elements, there's a quick trim. You can directly mouse pressing the left side of the mouse and dragging your the line, you see it will delete all the intersection lines. So it is the another method of the deleting. So this is the how to make the quick trim. Just pressing the left side of the mouse and dragging along the lines, unnecessary lines you want to trim or delete, you can say that. Okay, is it clear? Okay, good. Just a moment. Okay, next function is the here make the corner. Sorry, first is a quick trim, a quick extend. For example, if you have the systems like this, for example, vertical line and the horizontal line, and I want to make the extent of this line until this intersection of this horizontal line. In this case, I use here the quick extend and select, and I go to this. You see it is extending until the intersection of this one, and if you go here you see it is goes to the intersection this one, and if I select this one it goes to the intersection this one. If for example I select this side, you see it is not extending, since there is no here any intersection of the line or any sketch. It is in the space, so it is not extending. For example, if I draw here the arc and go to the quick extend and I select this one, so you can see it is extending until the arc. This is the how quick extend is the working. So it is very also the very useful element, and with the examples we will see how to use this quick extend. So next is the making the corner between the two lines. For example, if I have this line, and for example if I do this line, so I want to make the corner between this line and this line. So in this case use either this make corner function. So I select this one and I select this one, you see they intersect in the intersection point, making the corner. Okay, for example, you can select this one and this one, you see it is the intersects and trims other parts. So this is the hub to make the corner between the two two lines. So this is the trim recept curve. This is the how it's used. For example, if you have, it is the mostly used with the solid elements. So solid elements. So in this case, for example, if you have the rectangle and I want to extrude it with, I want to make the solid element. So in this case, it is the extrude. We will see this in the coming lesson, the function of the extrude, but now I have to explain this concept in order to do this. So sorry, let's finish it. Sketch. So I want to finish and I want to extrude only this rectangle. You see it is the extruded. So let's make it bigger. Sorry with the visualization. Let's delete this one and extrude maybe this one. Okay, with the problem with the visualization, let's I open a new file. It is the better. So sketch this one. Let's make a rectangle and I want to extrude it. Anyway, it is the problem. I don't know. Too big. Here. This one is that's why. Okay, now it's okay. So here we have the, I want to create a new datum plane. So I will explain all this later, but now I have to explain this trim. So that's why I'm using these functions. So it is the datum plane is created at a distance. We will see all the functions step by step. So I want to draw the line here using the profile. Sorry, let's make it here. Finish the sketch. You see the line is created on the plane. I want to make the copy of this line on this surface. In order to do this, I will select the sketch and select this face, press OK, and here we have the function of the project curve. So I will select this curve, so press OK. You see this is the projected, this curve is projected here. So you can also see that I used this projection curve in order to project this curve on the surface of this. This is the also the information for you. Now I will use this function. Where is this? This is the trim the receipt curve. How it is used? We can hide these ones. So we can hide this one, and I used this function. This is the user that's we have to select the curves. Here is selected curve, and here I select, for example, this edge. and discard here. You see, it is the disappeared until the I selected this line. There's a trimmed. Only this part on the surface of the workpiece is the remainder. So let's come back here. You see it is now active. Explain one more time how to use this trim recipe expert. So in this case you have to select the curve here. Yes, I selected, and here you have to select the border of the corner here, in this case here, and here you have the region. So you have to make the discard or the keep. If I select the discard, it means that this region is deleted. If I select the keep, it is the keep, and but this region is the deleted. For example, let's see the this one and press OK. You see, I made keep this line and it is the deleted. Vice versa, you can make deleted this part and keep this one, like here again. Oh, this one. So select the curve. Be careful here, it should be the connected curve. So select this one, it is all selected, and select the edge here, the trimming edge, and here I want to make the discard. It means I want to delete this part, the keep this one, and OK. You see, and it is the keep it, and I can finish the sketch. So this is the how is obtained. See, this is the deleted and this is the keep it. And in this case we have seen two things. So it is this one trim curve and the project curve, that is the projected our the curve onto surface of the workpiece, so in the solid element. But project also use it with another methods. Also you can use it, for example, I want to make the for example, this is the use it with another proposals. For example, let's see. For example, let's sketch on this surface, press OK. What I want to do, just using the project curve, I want to make active this edge. For example, this edge, this edge, this edge, and this edge, and press OK. You see they become the blue and they will become the active lines. So if I would like to make extruded, and you see it is the extruding, it will become active line. So it is very useful tool when making the complex shapes. Also it is the how to use the project curve to make the active of the edges of the solid elements, extruded elements. So is it clear the two methods? Because this one project curve is the more important, okay, this one, because we use this a lot of time when making the when we making the projects, okay, we will use this very often. This is the important, you have to learn it well. There is the two methods to use this one, to project the curve here, also the project also the existing edges of the solid elements. So switch to the go to the this one. So if it's clear, we can continue. What we have to learn now here, move the curve. They are not so important. They are not so important, but I will briefly just explain this one. So you can just move your element. For example, if you have the line, you can move from one point to the another point. That's all. It is not so difficult. For example, I want to move this one. Okay, I selected my curve. You see the arrow is created. Can move. You see up and down. Also from here you can check the axis, specify the axis. You can check the specified axis by the clicking here and select this axis and move horizontally. That's all. It is not so important. if you want to move, for example, this element, you can just, if it is not fully constrained, you can just drag and the line to move, not to use especially this move the curve function. So this is also the almost a movement. It is making the offset. So for example, select this one and you see arrow here. You can make offset here up and down. Also here you can give the value, for example, offset of the 200 millimeter from the beginning. So it is just making the offset of the curve. See, it is also movement. It is other than not so important. So the important one, let's see that this one, also this one, and we will see other important elements like the offset, pattern, and mirror. So this is what is the offset we have seen, and this is, let's see, this is the scale the curve. It is the making the bigger. You can change the value, for example, select this one and drag and drop, drag. Okay, you see it is increase the value. Let's see again, scale, select the curve you want to scale, sorry, okay, scale, okay, select the curve, and you can decrease or increase the value length of your. So next one is resize the curve. The resize is you will redefine the size of the curve. In this case, only circle and the circular elements, not the linear. For example, select the circle and go to the resize curve and select this one and drag this arrow. You can see, you can resize and press OK. It will become bigger circle, only with the circular elements. Next one is to resize the chamfer. In this case, we have create the chamfer. For example, chamfer between this line and this line. You see the chamfer is created, and I will go to the resize chamfer function. So this one. Okay, I don't know why it is not selecting. Okay, let's draw another chamfer maybe. So with the rectangle. It should be the symmetric chamfer. Sorry, always be careful. Only symmetric chamfer. So in this case it's symmetric, and go to the resize the chamfer. So select this one. You see the value is created, and you can change by the dragging or inserting value here as you want. So the chamfer is the resized. Be careful, it should be the method of the chamfer must be symmetric only when you want to make the resize. So next is let's, in order to do this, let's draw the one more element, for example, in here. Okay, what I draw the line. This line and this line. Next is the delete of the line here. For example, if I want to delete this line, I delete this one, but these two inclined line will intersect with each other, for example. So you see it is the intersecting and it is deleting. Okay, so you see it is the intersecting. This is the function of the delete. So we have seen that this all of them, and now is this one, offset, pattern, and the mirror is the important one. So you have to learn this one is the well. So in order to do, see, let's draw the one thing, for example the rectangle, and let's make for example the fillet here. So fill it in the both corners with the 100 radius, millimeter of the radius. So our element is ready, and I want to make the offset function use the offset function. I select the offset. Here I select the curve which I want to make the offset. In this case, this curve. You see, it is the making the offset on the this direction of this element. Directly copy it with the distance of the here 100. You can change it the value, for example 200. You see, it becomes the larger, or you can move by yourself. Here you see the function of the symmetric offset. If I select this one, if I activate this select symmetric offset, you see it is directly moving in the both sides. And you see, let's make it smaller. You see, it is the moving in the making the offset in the both sides from the upper and downward direction. So it is the how offset is working. It is a very useful tool. So let's go back again to the let's go here, and there is okay, let's oh sorry, let's go make fillet again. One more thing with the offset, if I want to make the offset this line in a symmetric way, and here in the setting, here the function of the convert input curve into reference line. It means that in the middle is the input curve. So if I activate this one, this will become reference line. So I activated it and press OK to see the result. You see, middle curve, which is the input curve, will become reference line. So these two will become active line. In this way, you can just make the extrude just to see the result. For example, you see it is the extruded. How to obtain the element like this? So press OK. So this is the how works the offset function. Let's go on with the mirror. So let's go the further here. Okay, but we need the axis here for the mirror. Let's mirror curve. What does it mean? For example, if I have the circle here and I want to make the mirror of this circle around this axis, and in this case I use the mirror function. So here I select the mirror. Here you have to select the curve where you want to make the mirror, this circle, and here I want to make the center line to make the mirror. In this case, this one. You see, it is the mirror. Apply. If I want to make the mirror around this axis, so select this line and select. You can also select this both of them. You see, it becomes two, and select the center line. So press this one. You see, it is the mirror around this axis. So let's make the distance higher here in order to see the result better. Okay, let's make it 20. Sorry, here. Okay, let's delete it. Let's by hand this one, and I want to make the mirror around the x-axis, this curve and this curve around the x-axis. You see, it is the mirror. The distance between this one and the axis is the same between this one and this one. This is the how is the mirror function is operated. So Is it clear up to now? Yes, of course. There is the tools, the boolean tools. So we will see, because we have not started with yet with the extrude functions. Maybe tomorrow, or maybe in the Friday, or we will start the extrude. So in this case, we will see there is several options of the boolean of the extrude. So we will see them. So okay, don't worry. Just today, in this week, we have to finish with the two-dimensional sketch. So don't worry about the extrusion, and we will see. It is the I have the plan for this also. Okay, this was mirror. And the next function is important, the pattern. So you can have the linear pattern, or circular pattern. So let's see the linear pattern. For example, I have the circle, rectangle, and I have the circle here. And I want to increase this circle along this line, or along this line. Number of the circles I want to increase. In this case, I will use this pattern function. I activate this one, and you see it is activated, and you see here you have linear, circular, and general pattern. We will see the circular and linear pattern. Firstly, let's see the linear pattern. So linear pattern. So here you have to select the curve where you want to make the pattern. In this case, in our case, I want to increase this circle. I selected it, selected the linear pattern, and here direction 1. In the direction 1, you have to specify the vector or line where you want to make the pattern. Let's direction 1 as this one. You see it is here, and here you have count and pitch, the methods of the pattern: count and pitch, and count and span, and count and pitch and span. What does it mean? Count and pitch. Let's see what is the count and pitch. First one, count and pitch. If, for example, you have the circle and you want to increase the circle number of the circles like this, in this in this way along this axis. For example, let's make the 4. Okay, count stands in this case, example 4. Okay, pitch stands distance this between these circles, pitch. Okay, so let's see with the example. In this case, count and pitch. The count, let's make it a 4. Pitch, let's make it a 10. So if I 10 is, I think, small. Let's make it 30. 30 is still small. 100 also is small, I think. Let's drag in here. 2000. Okay, too big. Okay, in this case, count is the 4. 1, 2, 3, 4. Okay, pitch is the distance between this blue line, distance between the center of the circle. This is the first method. Second is the count and the span. Count and span. What does it mean, count and span? You can choose any method as you want. Count and span. That count and span. In this case, for example, if you want to make the circles the same in the linear dimension, make the pattern, count the same stands for the 4 number of the holes, this one, circles. Span stands the total length here between this one and this one. So this is the span, okay, total length. in this case, in our case, span is the, here you see the blue line, blue arrow, is the 6000 millimeters. So next is the pitch and the span. In this means, so you see pitch is the same distance between the circles is the 2000, in this case not 4 but distance, and this is the 6000 is the total length from here to here. It is the only in the direction one. Is it clear up to now? The methods here, the spacing, this three spacing is clear how to, and according to your wishes, you can define the all. You can use one of them. Okay. If it's clear that I can go on with this. So this is the direction 1. Also, you can activate here the direction 2 here and specify the direction 2 vector. In this case, let's this one. And you see it direction 2 is activated here. And here you see method. Let's make the count. There is also the, we can make the same spacing. Let's make count and pitch. So in this case, you can change the direction here on the upward and downward. So you see here, let's make 3. Also, there is a symmetric should be, where is the symmetric? I couldn't see the symmetric value. Okay, don't worry. So if I press OK, I obtain my element like this in the 2 direction. You can use the direction 1, direction 2 as you want, or both direction in order to increase the sketch, the part. So this is the how to use it. So most important things is to define the distance and the counts, and properly define the distance and count. This is the how is the linear pattern is obtained. Let's see now circular pattern. In order to do this, I will draw the circle here, and let's finish it, and let's make. So I will draw the circle, and for example, I can draw the rectangle here, and I want to just let's make in the proper position. Let's make symmetric. No, it's okay. Circular pattern in this case. So layout is a circular. So here select the curve. I want to select, you select this curve, you want to make the pattern, and here you have to specify the point, rotation point, center rotation. Here in this case, this one, you see the pattern is created in the circular way according to this angular position. So first one is the count and span. For example, count and span. It means the count is the same 6 number of the rectangle, 1, 2, 3, 4, 6, and span is means the total angular length of the distance. Since it is a circle, it is the 360. For example, if I write here 180, they will locate into 180 degrees 6 number of the rectangles. So you can check it with the 270. You see it 270 degrees 6 number. So here let's make 360 initial one. So in the total length, it is the count means 1, 2, 3, 4, 5, 6. Span means total degree. So in the pitch, it means angle between the elements. Count and the pitch. In the case of the angular, in the case of the angular, count and the pitch means if I have here this one, count is the counts of this numbers. Pitch is the angle between the two, between the elements. So in this case, is the, since in this case is our case is 60 degrees. So this is the 60 degrees. So this is the since 6. The same way pitch and the span, pitch is the angle between these points, and the span is the total length. In this case, it's 360 degrees. So this is the how it's obtained. Sorry, just to move. So press OK. You see, your element is created with the angular and linear way. So is it clear, this one? Can you give some points? Angular and linear. Okay, good. So we have seen this one, and intersection curve. So this is also the important. Mostly this intersection curve, for example, this one intersection curve, and this one is the mostly used with the solid elements. Solid element, you will get sketches from the solid elements, and I will just show how to obtain this one, how to obtain the sketch with the solid elements. For example, let's finish and make some make one cylinder element. For example, this one. Increase it, and let's make it scale is too big. So like the cylinder one. So and make the one datum plane on the cylinder. For example, the datum plane, we will all I will explain the all everything. So datum plane on the middle, you see, datum plane I created on the middle of this one. Press OK, and the visualization is, the scale is too big. That's why so I will sketch this on this plane. Press OK. So let's select the intersection curve. So I will select the face of the cylinder. Press OK. You see, curve is created here. This curve is created directly, exactly on this plane. This plane, you see, intersection with this cylinder surface. This is the how intersection is obtained. So I will show one more time. Let's go back here. You see it is deleted. So I will go to the, let's finish. I will go sketch. I will select this plane directly. Press OK, and go to the intersection curve and select this face. You see here it is the created. Press OK. It is very important because with the surface elements you can create such kind of lines on the surface elements in the advanced level. So let's hide this one, and let's make another example. For example, okay, let's finish it. Let's draw the again create the datum plane. For example, using the at a distance from this distance. For example, here, and press OK. And I want to make the intersection of this, create intersection of the discourse with this plane with this cylindrical element. Okay, someone is too late. Okay, let's admit. Okay, I will explain one more time later with the linear and the circular. Okay, just finish with this one. Okay, just a moment. Okay, let's sketch this one. Press OK. So it is the go to the intersection curve and select this face, press OK. You see, intersection along the here is created along the this datum plane. So should I explain the pattern function, circular and linear, one more time? Because there is some misunderstanding. Alan, can I explain again? Alan is here. Yes. Alan, can you hear me? Can I explain the... If no, I can continue. You can by yourself one more time to see the recording. So there is no answer. So this is the how to obtain the intersection curve like this. But don't worry with the practices. We will see these functions many times because it's very oftenly used functions. Next point is this one. In this case, it's the intersection point. Intersection point uh, with the curve. This one is also very useful tools when we are making the surface element with the complex shape. So let's see with the one example. In order to do this, I'll open the new file. For example, I have the sketch here. For example, I have a circle and finish it. And on the another plane, for example, on this plane, sorry. For example, on this plane, I want to draw, for example, arc here first. Any arc with any dimension. So any arc, and I want to connect this point with this point. So I can use the geometric constraint. So here the coincidence, but sometimes it is difficult. You see, it is goes to the center. So it is better to create here the point in order to just connect this point and this point. In this case, I will use here. So you see this plane is active. Since this plane is, if I extend this plane, it intersects directly on this point with the point of this. So if I use this intersection point function here, you see, it directly creates the point with the intersection of this datum plane. So here it is the activated intersection point, and I select this line. You see here point is created. Can you see here the point is created, and press OK. Now with easily using the geometric constraint, I can connect this line. So with the coincidence, 2 points. This point, you see, it is difficult to select. Let's deactivate this one. This point is selected, coincident with this one. So you see, it is the coincident directly. Why do we need this kind of coincidence? In the surface element, for example, if I want to make the surface element of this circle along this line, it should be connected. If they are not connected, I cannot extrude this one. For example, let's see with the swap function here. We will see this swap function. I'm just give the example. I select this function. So let's finish it firstly. Here the swap function. I want to make the swap extrude this circle. So here the extrude this circle along this line. So you see it is the extruded. This is how it's obtained. So this is the important here intersection of this arc with the line. So this is the obtained by the intersection point curve. So with the let's with this one. So it is the important, very important in the surface element. So is it clear? Is it so they are not so important, these ones. Just I can show, for example, if you have the line, you can make this line, just increase the lines like this, that's so, and here the derived lines, and here you can optimize the lines, this line and this line, and press OK just to remove constraints. You see here it is the parallel, and if I press this, they will not become the parallel. So and this one is used in order to convert the other format is the sketch into the NX, for example aftercut and so on. So everything here is explained. Today we will discuss tomorrow we will discuss a little bit about some constrained system. It is important. Also sketch filters, that is located here. Then we will make some practices. So now let's make some practice, and we can then finish our lesson. So everything is clear, all the concept, all the sketch, or should I repeat one more time some misunderstanding things? Students, are you here? Just can you hear me, or okay? Question is clear everything? You can make the practice by yourself by following the recordings, and because you have to do this, you have to make everything by yourself. Maybe now you couldn't follow me just hearing and listening me and looking for, but by yourself you have to do all the projects. Okay, if you have the questions you can ask. Maybe let's firstly I will upload the recording, and let's make follow the recording by yourself firstly. If there is some doubt, some question, then we can discuss in the next lessons. Okay, now let's continue with the practice. Good, good. Okay. Today we will try to do some more practices, 2 or 3, maybe more. This is too simple. Anyway, it is useful for you to make the practice and practice and practice in order to acquire all the elements of the NX. So I select a sketch as usual. Select, for example, this plane, then press OK. So we can start with these 2 circles with a diameter 45 and 30. So rapid dimension. This one is smaller, 30 millimeter, and big one is the 45. So I would like to firstly draw this rectangle. So with the 15 and 120 millimeters. So rectangle. Let's select the rectangle by center. From this center, you see, dash line represents the center. So dimensions is here 15 and length 120. So let's make it symmetric around the y-axis. So symmetric. This one is the symmetric around this axis. So let's define now in the distance here. Distance between this one is the center of the circle is here the 65. So I located it, and I can draw for example, this arc is the 25. There are the tangent. Select the arc here. Select this line and this line. So let's check the tangency. Is the constraint. This one and this one tangent. Here all of the tangent, and this one is the 25. So now draw this inclined line. Distance here is 8.3. So there is the tangent, so it is okay. We can use the offset in order to obtain this line, since the distance is the 14. So using the offset function, which we learned today here, offset, you see, select this line. So it is too big. Okay, it is the 14. So it is the symmetric now, but we have to deactivate here the symmetric. So only in one direction. Press OK. Sorry, it was activated. Convert to the reference. Offset. This line. Here the deactivate here. Okay. So now using the quick trim, I will delete unnecessary parts. Sorry. Okay. So quick trim. Okay, I delete this one, and this one. So last one more step to make here fillets with the radius of the 10 millimeters. So I will select the fillet function and select this line. So type the 10. So next is this one and this one, 10 millimeter. Here it is the removed, so because of the trim, this line also we have to extend it. So extend. Now it's correct, and the sketch is the fully constrained here. It is the goal. We will see the constrained system, type of the constrained system tomorrow. So finish the sketch. So this is the sketch. This one, first one. Okay, you can continue. with another example. So the first one, and let's make the open this one. So open the new file. Okay, press OK. As usual, select the sketch, plane. Okay, let's analyze the sketch. So here is the elements. We can start as usual from the center and draw this part and make the mirror. So we can use the mirror function. So let's start the circle with the diameter of the 88 and the rectangle, the size of the 130 and 160. Okay, circle. Let's rectangle. You can use the from the center type of the rectangle. It is the more convenient. So to make the let's put the dimensions. This was the 88 and this was I think 160 and this was 130 and there was the fillet with the radius of the here 20. So let's make it a fillet using the fillet function. 20 symmetric fillet, be careful. Sorry, does not matter with the fillet. I confuse it. So 20. So we have finished it with the center element. Now we can draw this circle. Is the diameter is the 86. Here in any place for the beginning. 68. Sorry. Distance of this circle with respect to the center here, half of this distance, 110. I can make the now mirror of this curve, this circle mirror around this x-axis, so it is the mirror. Now I will draw these arcs with the diameter of the 240 using the arc. So diameter is the 240 and using the geometric constraint I can make this radius equal to with this radius. So here let's make the tangent. There is no tangent within this line with this one, and here also. So it is now tangent. I can make the mirror of this curve, selecting all of them around the center axis. This one, mirror it, press OK. Now draw this part. Here the radius of this circle is 60. And the diameter is 120. Here you can put this one and draw the arc here. So let's make tangent this one and this one. Sorry. let's draw the another arc in the more better position. So now and make the tangent. Now it's okay. The angle is here 240, also this one. So let's make the mirror of this elements, this circle, this one and this one around the y-axis. So mirror. Let's use the trim function in order to make the open under this sides. So we don't need this one and this one, since you see it is the mirror here, it's automatically this one is also deleted, this one and this one, you see. Let's keep now this one, draw the line here. Let's make like this. First draw line here, and using the quick extend, it is the more better here. Extend the line like this and make the same mirror of this line around this center axis. So it is the mirrored. And let's define some dimensions. So distance is here 380 between these circles, 380 millimeter, and the height is 280 at 200, yes. So there is some problem with because there is this sorry, it's correct, this one 200, yes. The dimension 280 at this dimension, let's define it. So dimension this one and this one is a 280, so it is correct. Now let's delete this ones also and this, sorry, because we have to delete firstly this one. So here you can make its reference one. So let's make here the radius is a 20 using the fillet. Type the 20 millimeter, press OK. So I think the sketch is almost finished, so let's finish the sketch to see the compare with this one. I think everything is okay. So this is the how to make the how to make the sketch. So in these 3 days we analyzed here all the functions of the direct sketch, two-dimensional sketch, how to make the geometrically dimensionally constraint using the rapid dimension, and learn the geometric constraints, all of options. Plus here we analyze it making the symmetric function. Where is it symmetric function, analyze it. So as I said before, you can reach for the sketch techniques by the menu, insert here the sketch curve and the constraints. You can use this one. So we finish it almost with group of the direct sketch here. Step by step we will go the here and here step by step. Before the going on, just I would like to explain tomorrow the important two theoretical aspects of the NX. Basically here there is the filters exist here for the sketch. So it is the important. Also I would like to explain about the constrained system, over constrained system, and the fully constrained system, and under three main constrained system. This is was also the important thing. So and maybe Friday we will start with the extrude or make practice. So it does not matter. We will see. So we can finish for the today. Maybe just you mean the sketch? Okay. You mean the directly the NX file, or you mean the okay PDF file? Okay, okay. I understood. I will send. Okay, for the making the practice. So don't worry. I will send. So thank you very much. See you tomorrow at the same time. Have a nice day.